Good morning, ladies and gentlemen, honorable two of the judges and the audiences here. My name is Cecilia Tiffanny and my colleague Noah Gregory Suryawinata from Santa Laurentia Senior High School, Alam Sutra. In this opportunity, we would like to present our research titled Development of the MQ2 Sensor with an Arduino Uno-based GSM as a LPG gas leak detection tool for households. This research is conducted due to several reasons. First of all, LPG gas is known to have flammable properties, and gas leaks are generally caused by human incapabilities of detecting LPG gas, for they are invisible. Other than that, based on the statistic, as much as 12% of fire cases are caused by LPG leakage, and in 2019, as many as 13,211 fatalities were caused by fire accidents. Lastly, it was recorded that in 2018, the number of active mobile phone users in Indonesia alone reached more than 100 million people. The problem statements of this research are as follows. The recent rise in fire incidents due to the leakage of LPG gas cylinders requires special attention to this type of fuel. Based on the data from Jakarta Provincial Fire Management and Rescue Service, in 2020, as many as 12 of the fire cases were due to LPG gas leaks. Due to these problems, the research questions are: how can an LPG gas detector be developed by adding the SMS feature? And does the sensor warning system with alarm and SMS work properly? Hence, the objective of this research is, first, to develop a GSM-based LPG gas detection system by adding SMS sending features and automatic closing of gas valves. Second, to test the success of the LPG gas leak warning system based on the work of the sensor, warning system, SMS, and automatic closing of the gas valve.
So the data flow of the gas sensor, at first the machine starts. The data from the MQ2 is processed by the microcontroller. Now, if the data, specifically the LPG concentration is more than 400 ppm, the motor closes the valve, the GSM sends the SMS, the GSM calls the phone number. Now, while the LPG concentration is more than 400 ppm, there will be an alarm and the function ends. So the research stages. First, we prepare all the materials and apparatus, and then these four functions can be done separately. The functions are LCD appearance, the alarm, the GSM system, and the servo motor system. Now, once these four functions work perfectly, we will test them all. We tested them all together. If all the four functions can work perfectly together side by side, then we proceeded to the next step, which is assembling the system into a tool, a permanent tool. The next step is the next slide is methods of processing and data analysis. So first we built the circuit, and then we program for the circuit, and then we run to test by spraying butane gas on the MQ2 sensor. And then if we were successful, we can proceed to the next step. If we failed, then we have to reevaluate and revise. Data of making the LCD feature. We failed mostly because of the display and the coding. The LCD succeeded in displaying the LPG, carbon monoxide, and smoke, and its concentration in units of ppm. The alarm, we failed mostly because of the coding. We couldn't figure out a rhythm or a music to make it sound emergent. But we succeeded in the 8th to 10th trial. When the gas concentration is over 400 ppm, the alarm from the buzzer will emit a sound with 110 decibels at a distance of 15 centimeters. The data of the servo motor. We failed mostly because of the circuit. The external power was too much for the servo motor, so we had to replace it. And the battery has an output of 7.4 volts. When the LPG gas concentration exceeds 400 ppm, the servo motor will turn the valve off. And that was at the 7th to 9th trial. The data of the GSM system. We failed a lot because of the not sufficient local internet connection for the GSM. The GSM has a SIM card which needs the correct phone credit and enough local internet connection to send an SMS and a phone call to the phone number. It succeeded in sending the SMS and the phone number when the LPG gas concentration is more than 400 ppm. The data of assembling the product. The MQ2 needed to be relocated because it couldn't fit inside the box. But the second trial, we succeeded in uh, running and testing it. All of the functions work perfectly, and the final product looks like this in the second trial. This is the demonstration video. So this is the gas sensor. There is an LCD display at the front, and there is LPG, carbon monoxide, and smoke with the concentration ppm at the bottom. There's the gas sensor and the buzzer on top of the box. Inside the box, there's the Arduino Uno and the GSM. There's the servo motor at the bottom, and that's a standard connector or a regulator for a gas tank. So the valve will be connected to the servo motor. It it switches on and off if it's moved to the counterclockwise. It's going to be connected with that metal thing. It's like this. And this is the butane gas canister that will be used to test the system. Uh, we should, if we pay attention to the switch or the motor, we can see that it moves when the butane gas canister is tested. There you go, it moved. And we'll get a SMS text message. There you go, and a phone call. Yep. The phone call would last about 25 seconds, and then there will be a alarm, and the LCD will change. There you go.
The conclusion of the research is the gas leakage detection system with the addition of the SIM900A GSM module can work well by sending an SMS and calling the user's cell phone number to give a warning when the detected gas concentration exceeds 400 ppm. Other than that, the LPG leakage warning system works well when the gas concentration is more than 400 ppm, includes an LCD that displays the gas concentration, an alarm for the buzzer, alerts via SMS and telephone, and also closes the gas valve automatically. The future work of this research is, first, adding an LPG gas neutralizing feature so that the leaking gas does not cause an explosion or a fire. Second, collect data for the accuracy of the MQ2 gas sensor, the probability of system failure, and the response time of the system. Thank you for listening to our presentation.